A true-false test has 150 questions, and a passing grade is 57% or more correct answers. Okay, so for part A, what is the probability that a person will guess correctly on one true-false question? Well, for just one, if we're guessing, it's either right or wrong, so that's going to be 50% of the time, or 0.50. So 1 out of 2. And for part B, what is the probability that the person will guess incorrectly? Well, that's the same for if they guess it correctly. You know, half the time they'll get it right, half the time they'll get it wrong. And part C says, find the approximate probability that a person who is just guessing will pass the test. And we're going to use the normal approximation to figure this out. So in StatCrunch, go up to Question Help and open up StatCrunch. I'm going to use the normal calculator. So let's open that thing up. So I'll go to Stat, Calculators, and select Normal. And what we're looking for is a probability that someone randomly guessing will get more than 57% of them correct. But what we need is the correct mean and standard deviation for this problem. So here, I took this 0.57, I converted it to a probability, and I'm asking, well, what is the probability that a person randomly guessing will get that score or higher to pass? So for the mean, that is going to be equal to this 0.5 here. So I'm going to put in 0.50. And for the standard deviation, we're going to use a formula, which I'm going to pull that up right now. So for this type of distribution, the mean is going to be equal to the mean that you start with, which is this number here. But if you want the standard error, you take the square root of this value times 1 minus that value divided by n, where n is 150, and you take the square root of this thing. That's going to be equal to the value we put here, the standard deviation. So p being 0.50 means 1 minus p is also 0.50. So let's bring up a calculator to walk through this. So the value of p is 0.5. I'm going to multiply that by the value of p, 1 minus p, which is also 0.5. I'm going to divide that by n, which in this case is 150. And then I take the square root of this number. And this is the corresponding standard deviation. So I'm going to put that here. That's 0.04082. I think that's the value I'll use, 0.04082. All right, so I'll move these things out of the way, and I'll click Compute. If we round this to 4 decimal places, the corresponding probability is 0.0432. So about 4.32%. I'll click Continue. And Part D says, if a similar test were given with multiple choice questions with 4 choices, would the approximate probability of passing the test by guessing be higher or lower? Well, in this case, if there were 4 options instead of like true, false, where there's only 2, this number is going to go down. It's going to be 0.25 instead of 0.5. What that's going to have the effect on is, well, it's going to lower this probability here. So it looks like of these 4 choices, D makes the most sense. It's going to be lower because the probability of guessing correctly on each question is lower when there are 4 options. So for this problem, I'll bring it back up here, but I need to use these formulas. For this type of new distribution, the value here for P I got from this number here, and I also need to figure out a standard error or standard deviation, and it came from this formula. But once I had that, I put it into StatCrunch, and I was able to compute this corresponding probability.